This is a demonstration on how to complete an independent samples t-test in SPSS, and I'm going to go back to the same datasets that I've been using for these demonstrations, and we are going to need two variables for an independent sample t-test. We need one variable that's going to measure something, and the other variable is going to be used to group the groups by. Now we need two groups for an independent samples t-test, so the variables that we're going to use are writing group and health. In this example, we are looking at two groups of people. One group engages in an expressive writing exercise, and the other group engages in a control exercise. So one group is going to do some expressive writing, and the other group is just going to write about everyday things in life. And we are going to see if there is a significant difference in the overall health rating for those individuals based on whether or not they engage in expressive writing or a control group. Okay. Now, we're going to use writing group to group by, and we're going to use health as our measurement. So we're going to measure health grouped by writing group. We can do this by going to Analyze, Compare Means, Independent Samples t-test. We put the test variable, which is what we're going to measure, into the test variable group. So the test variable is health, and our grouping variable is going to be writing group. Now, we have to tell SPSS which two groups to look at. Now, I know that there are only two groups here, so it's obviously just going to be 1 and 2. But let's say that we had a third group that wrote about health, and we wanted to only look at the people who wrote about expressive things and the control group. We would select those two groups and not the third one. But we only have 2, so obviously we're going to group 1 is going to be 1, group 2 is going to be 2. I click Continue. And I'm going to check the options just to see if there's anything that's interesting here. It looks like there's not. We're just going to leave everything alone. That's okay. And after we've gotten our test variable loaded and our grouping variable loaded, we can click OK. And we get some output. So we had 10 people in the expressive writing group that had a mean of 79. So the health scores for the expressive writing group had a mean of 79. The control group had 10 people with a mean of 68. So the control rating group, who wrote about just everyday things, had a mean health rating of 68. You can see the standard deviations and the standard error of the means for each group. When we interpret an independent samples t-test, we need to be sure that we are not accidentally interpreting the wrong coefficients. So for the variable health score, we're going to assume equal variances. There are times when we won't assume equal variances, and that's a very specific part of statistics that we're not going to cover too much, called assumptions. But we're just going to assume, even if this is not true, that the variances are equal, just for the sake of interpreting this in this class. In advanced statistics class, you'll have to make a decision on which of the two lines, the top or bottom, to interpret. But here we're just going to go with the top line, no matter what the scores actually are. Now, the first two columns here are part of a test called the Levene's test for equality of variances. We're going to ignore these. So we're going to read across the top, but ignore these first two. You'll be very tempted to say, oh, my significance is 0.766. That's not true. That's the significance for the test of equality of variances, not the test for the overall model. So our interpretation begins here. When we look at the expressive writing group and the control writing group, the difference between those is 2.425. Okay, that's our t-score. So it has a t-score of 2.425, meaning that the difference is 2.425 standard deviations above the mean of 0, where 0 indicates that there is no difference. So there is a difference. The difference is 11. The mean difference is 11, and that's calculated by taking the mean for first group minus the second group, which gives us 11. The standard error of the difference is what we calculated by hand in the lecture, but this is a calculation that tells us what this combined amount of standard deviation there is in the distribution of means for each of those two groups. Okay? That's just an interesting thing to bring up because you can rebuild the t-formula by using the standard error of the differences and the mean differences. As a matter of fact, if you take the mean difference and divide it by the standard error of the difference, you get your t-score. There are 18 degrees of freedom, which is the number of groups in group, or the number of people in group 1 plus the number of people in group 2 minus 1 each time. So it's n minus 1, which is 9, plus n minus 1, which is 9. 9 plus 9 equals 18. The significance for our test is 0.026. That is a significant difference because it is less than 0.05, meaning that the difference between our groups occurs less than 5% of the time based on the comparison distribution, when this actually occurs 0.026% of the time, which is about half of the significance that we need in order to be significant. So this happens 2.6% of the time, which is much lower than 5% of the time. So the interpretation here is that we have a significant result in that there is a significant difference between the two groups when we are measuring health score. If you have any questions, feel free to reach out. Otherwise, I look forward to seeing what you can produce.